Okay, we're talking about section 9.7, which is we call unit 7, and it's about asymptotes and holes. So I'd like you to we're just going to jump into the worksheet because we have very little time today because of the activity we did in class. So I want you to remember, I've told you before, if you can factor, then you should factor. So do you see that on the bottom you can factor there? Everybody go ahead and factor that out and rewrite it. It'll be x minus 3 on the top. And what will it be on the bottom? 3 comes out, and then what do you have? X minus 3. Okay. And notice that there's 1 on the top and 1 on the bottom. Well, of course, you've learned by now that you can cancel that. That's one of those top 20 things we just practiced. Boom, boom, it's gone. Does that leave nothing on top? No. It leaves what on top? A 1. So the answer is f of x, which is the same as y. Y equals 1/3. Okay, now it's sort of like a politician that has a skeleton in the closet. It is a equation. It looks like it's just a line, y equals 1/3. It would be a line that runs along like this at 1/3, which is, like let's say this was 1. Then 1/3 is kind of, just off the x-axis. But it's got a dark secret. And that is, in its past, if you had ever put in a 3 into this equation, you would have had a 0 on the bottom of the equation. I don't know if you know this, but you're not allowed to have a 0 on the bottom. Did they ever teach you this in elementary school? That like 7 over 0 is not allowed? It's an error. It's called undefined. Okay? So this guy's got a hole there. What that means is if you had ever put in 3 into this equation, every other number in the whole thing works except that one spot. Right there, it would have a weakness, a hole. So that's called a hole in the function. All right? So where is the hole? The hole is at, well, x equals 3, comma, what's y equal to? It says it right there. 1/3. That's the hole. All right, let's look at number 2. Well, this one's pretty obvious. It's just sitting right there in front of you. The x plus 5 and x plus 5 cancel. Just don't forget to make them 1 over 1. So y equals 1. So if I were to graph this, you don't have to. It doesn't say you have to. But if I were to graph it, it'd be a line going across at y equals 1. But it's got a secret. Its weakness is what? What could you have put into this function that would have caused a 0 to be on the bottom of the fraction? X equals -5 is its weakness. So you just put that together in a point. If you had put in -5 at this spot, -5 comma 1, you'd have had a hole. -5 is right there, empty spot right there. That means on this graph, you'd have had a hole at -5. Every other spot would have worked. You could put in any other number in here, and it doesn't have a problem with anything except -5 is its issue. Okay, let's move on to number 3. What factors? Top factors out. What do you get? 2x plus 3 all over x plus 3. Notice me putting parentheses around them. That's what you probably should do. And then these guys cancel, and they don't just disappear. They turn into 1s. So it's 2 times 1 over 1, which is 2. So y equals 2. If I were to graph it, it's a line at y equals 2, but it's got a secret. It's got a weakness at what? -3. See, -3 is what would kill it. So there's a hole at -3 comma 2. Catching on to this? Okay, now number 4 factors is just a little different looking. The top part will factor, cancel off stuff. And this is actually just like one of the top 20s. It's just that you're learning what happens at that spot is that it creates a hole. All right, now let's look on. I'm going to assign you less problems than normal. I'm assigning you the evens off this assignment because of the time pressure that we have today. So just do the evens. Let me help you then with number 8. It factors on both the top and the bottom. 2 comes out, actually 2x comes out, and what do I have left? X plus 1 over x squared minus 1. Ooh, I know that one. What does that factor into? X minus 1 and x plus 1. Very good. That's one of those difference of squares kind. That's just like the top 20 kind. And then once this cancels, it's still just like the top 20 thing. The answer is what's left. There's your answer for y equals that. But the question is, what is the whole? Okay? And it's asking about holes in the graph. The whole is at, what's its weakness? That its weakness is -1. And the other part of the whole is this. I will teach you more about how to find that later. I'm going to pause for a second because there's a lot of people talking right now. Okay, so I'm just reminding you, the class ended, but I'm going to finish this video here. I want to remind you how to do the rest of this problem. We were doing the whole, and we figured out that -1 would have crashed this function, because if you put a -1 in right there, it would make a 0 on the bottom. So the whole then is definitely where x is -1. The question really is, where's the rest of the whole? And the rest of the whole is going to be when you put the -1 into this function right here, which is y equals 2x over x minus 1. When you put in the -1 in there, you'll find out what y is. Because see, a whole is an x and a y, and I already know the x is -1. And the other part of the whole is the y. So I'm going to put in a -1 right here, and a -1 right there. Nope, -1 actually right there. There we go. And now I get -2 over -1 minus 1, which makes -2, and that's equal to 1. So the y of it is 1. So there's my whole. The first thing you do is find out what crashes your function that has 1 on the top, 1 on the bottom, and that -1 right there makes the x of your whole. Then you plug that -1 in here, and that tells you the y of your whole. All right, now the domain. The domain of these graphs is always everything works except, so I'm going to write all real numbers except, if you look at this part, the part we factored into x minus 1 and x plus 1, everything works except two things, 1 and -1. So we say all reals except x cannot be 1 and x cannot be -1. All right, those are the two things that would crash my function, because if you look down here, that's the two things I could stick in that would make the bottom 0. And then the last thing you have to answer is vertical asymptotes. To get your vertical asymptotes, they are either this or this, and if one of them is a whole, which we figured out -1 was a whole, if that's the whole, then the other one must be the asymptote. And so that ends up being x equals 1 for your vertical asymptotes. All right, I want to show you one more from beginning to end, and I'm going to show you number 7. Okay, so I'm going to say domain for number 7. Domain is all real numbers except what would crash it? -3, +5, and +2. So x cannot be -3 or it would crash. X cannot be 5 or it would crash. And x cannot be 2. All right, so there's your domain. Now the vertical asymptotes, these guys right here are either vertical asymptotes or they're wholes. See, the point of something not working in a function is that it either makes an asymptote or it makes a whole, one or the other. So this right here would make a whole at the 5. That one's making a whole. So I'd say x equals 5 is going to create a whole, and the other two are going to be the asymptotes. So if this one's a whole, then this one must be a vertical asymptote, and that one must be a vertical asymptote. So x equals 2 is a vertical asymptote, x equals -3 is another vertical asymptote. Okay, so my whole, I can't just say 5 though. You got to be a little more advanced than that. You got to say the whole is at 5 comma what? And now you take that 5 and you stick it into this resulting function up here. Of course, we don't want to put it into that place where it would make it equal 0, where the whole thing's just going to turn into 0 over 0. So we leave this canceled out, and we drop a 5 into the equation. And on the top, you'd have 5 plus 2 is 7. Over on the bottom, you'd have 5 plus 3 is 8, and 5 minus 2 is 3. 8 times 3 is 24. You get 7/24 when you put in x equals 5. All right? So it's wholes, vertical asymptotes, and domain. Don't worry, we will spend more time talking about that on Monday. All right? Have a great day.